You walk into a pharmacy and buy antibiotics without a second thought. A scraped knee, a sore throat, a minor infection, you take a pill and you forget about it within a week. But for most of human history, that same infection could kill you, slowly, painfully, and there was nothing anyone could do about it. Then, in the summer of 1928, one man's messy laboratory changed all of that forever. Not through years of careful planning, not through a brilliant hypothesis chased to its logical conclusion, through an accident, a mistake he almost threw in the trash. This is the story of how the world's most important medicine was found by a scientist who wasn't even looking for it. You have to picture the lab first. It's cramped, it's cluttered, Petri dishes stack up on every surface, some of them weeks old, some of them forgotten entirely. The scientist working here has a reputation, and it isn't for tidiness. His name is Alexander Fleming, and his colleagues already know him as brilliant but chaotic. He leaves cultures out, he lets things sit, he goes on vacation without cleaning up. That habit is about to matter more than anything he ever did on purpose. Fleming had spent years studying Staphylococcus, a bacterium responsible for everything from minor skin infections to fatal blood poisoning. Before antibiotics existed, doctors had almost no defense against it. Wounds turned septic, surgeries became gambles. Something as small as a splinter could become a death sentence, and Fleming knew this better than most. He had served as an army doctor during World War I, watching soldiers die from infected wounds that a clean bandage couldn't fix. So he searched for something, anything, a substance that could kill bacteria without killing the patient too. Most of what he tried either didn't work or was too toxic to use on a living body. Year after year, the search went nowhere. Then he went on holiday. In September of 1928, Fleming left his lab in London for a family vacation. Before he left, he stacked up a pile of petri dishes containing Staphylococcus cultures near a window, intending to clean them later. He didn't seal them properly. He didn't refrigerate them. He simply left. When he returned weeks later, most of the dishes were exactly what you'd expect: ruined, overgrown, useless. But one dish was different. A patch of mold had grown on it, likely drifting in from a lab downstairs that happened to be studying fungi. And around that mold in a clear ring, the bacteria were gone. Not weakened, not slowed down, dead. Most scientists would have tossed the dish without a second look. Contaminated cultures were common, annoying even. But Fleming paused. He looked closer. Something about that ring bothered him in the best possible way. What was killing the bacteria? He identified the mold as a strain of Penicillium, and he began testing it obsessively. He grew more of it in broth, then filtered out the mold itself to isolate whatever substance it was producing. He called that substance Penicillin, named simply after the mold that made it. When he applied it to other harmful bacteria, the results were consistent. It killed them. Streptococcus, diphtheria, even the bacteria responsible for gangrene, all wiped out by this strange broth from an ordinary bread mold. Fleming published his findings in 1929. And here's the part that surprises most people. Almost nobody cared. His paper described penicillin's antibacterial properties clearly enough, but it barely mentioned its potential as a medical treatment. Fleming himself struggled to grow enough of the mold in usable quantities, and the process of purifying it was frustratingly unstable. It broke down too quickly outside the lab to be practical. For a decade, penicillin sat mostly forgotten, a scientific curiosity rather than a cure. It would take a different kind of team to finish what Fleming had started. At Oxford in the late 1930s, a pathologist named Howard Florey and a biochemist named Ernst Chain came across Fleming's old paper while researching natural antibacterial substances. Where Fleming had discovered penicillin, Florey and Chain understood how to turn it into medicine. Working with a small team that included Norman Heatley, they spent years refining the purification process, testing dosages, and figuring out how to produce penicillin in quantities large enough to actually treat a patient. Their first human trial came in 1941. A policeman named Albert Alexander had developed a severe infection from something as small as a scratch from a rose thorn. It had spread across his face and lungs. He was dying and nothing else had worked. They gave him penicillin. Within days, his condition improved dramatically. His fever dropped. His infection began to recede. For the first time, the world had proof that this strange mold-derived substance could save a human life. But the team ran out of penicillin before Alexander fully recovered. There simply wasn't enough of it. He relapsed and died weeks later. It was a devastating outcome, but it revealed exactly what needed to happen next. Not more science, more manufacturing. With World War II escalating and infected wounds killing soldiers by the thousands, the pressure to mass-produce penicillin became urgent in a way peacetime research never had been. penicillin. American pharmaceutical companies, working alongside British researchers, developed new fermentation techniques that dramatically increased yield. By the time Allied forces landed at Normandy in 1944, penicillin was being produced in large enough quantities to treat wounded soldiers on the battlefield. What had once been a struggling lab curiosity was now saving tens of thousands of lives a year. Fleming, Florey, and Chain shared the Nobel Prize in Physiology or Medicine in 1945 for a discovery that began with a dish nobody bothered to clean. Here's the part worth sitting with. Fleming wasn't hunting for a miracle. He wasn't running a controlled experiment designed to find it. He simply noticed something unusual, and instead of dismissing it, he asked why. That single question, asked in a cluttered lab in front of a ruined petri dish, eventually saved more human lives than almost any other discovery in medical history. Before penicillin, roughly 1 in 9 soldiers with a bacterial infection died from it. After penicillin became widely available, that number collapsed to nearly zero. Historians estimate antibiotics derived from Fleming's discovery have saved somewhere between 200 million and 500 million lives since. Think about that number for a second. It came from a mistake he almost threw away. You live in a world shaped by that accident every single day, every surgery you might one day need, every infection your body doesn't have to fight alone, every scraped knee that heals instead of festering. None of it required a genius plan. It required one tired scientist coming back from vacation, noticing something strange, and refusing to look away. The next time you swallow a pill without thinking twice, remember what it actually took to get there. Not a straight line of brilliance. A messy desk, an accident, a question nobody else thought to ask. You walk into a pharmacy and buy antibiotics without a second thought. Now you know exactly what you're really holding.